All right, I'm going to be recording how to do these unit conversion problems from the worksheet that involve switching from one unit in the metric system to a different unit in the metric system, where both of those units have prefixes. And my preferred way of doing these conversions is to go through the base unit. So let's just note, first of all, that the base unit for this first problem is going to be meters. The base unit for the second problem is going to be grams. For the third one, it's liters. And for the last one, it's watts. So notice that that base unit is coming from whatever the letter is in the unit that has a prefix attached to it, right? So the letter essentially on the right-hand side of the unit. In doing all of these, in pink here, I'm going to indicate what I call my roadmap for unit conversions, which is I like to think before I get started about the units I'm starting with and where I want to go and what steps I'm going to take to get there. So for example, my roadmap for this first problem is going to be that I'm starting with kilometers, I'm going to convert into meters, and then from meters, I'm going to take this into picometers. If I go through the base unit on all of these are all going to look very similar in that I'm starting with a unit with a prefix, I'm taking it to the base unit, and then I'm switching from the base unit into the desired unit, the unit that we're trying to convert into. So for this next one, it's going to be nanograms that are going to go to grams, and then I'm going to go to milligrams. For this next one, it's going to be microliters to liters, and then from liters, I'm going to go to megaliters. And for the last one, I'm going to have gigawatts, and I'm going to go to watts, and then from there, I'll go into milliwatts. So just notice how each one of these problems has a very similar flow to it, right? We're starting with one unit that has a prefix, we're going to the base unit, and then we're going to finally convert into whatever our desired unit is, which also has a prefix. And this sort of sequence of steps is done really frequently in a lot of situations with chemistry. We're going to see it pretty early on when we get into the sort of the chemical physics behind light and all of that jazz in a couple chapters. So it's really beneficial to start getting used to this process now so that you know what we're doing when we're applying it to higher level concepts. For this conversion, you need to know what the prefixes mean in terms of their factor of 10. And so up here we have the prefix table, which defines each one of these prefixes in the metric system, what the symbol is for that prefix, and what its factor of 10 is. And that's represented both as the exponential, so kind of like the scientific notation way of expressing the unit, and then the factor. And the factor and the exponential are both relating back to the base unit. So if you notice here, the base unit is given an exponential of 1 or a factor of 1. And so what you're looking at here is how these other units compare back to the base unit. Now I'm going to be utilizing this table to come up with my conversion factors for each one of these problems. And you want to make sure you get comfortable with how to do this. I'm going to walk through it step by step. But the other thing I'll remind you is that you don't need to memorize this table because I'm going to provide it to you on all exams and quizzes. So this is not something you have to have memorized. The more you use it though, the more you will probably start to memorize some of these things. Okay, so for this first problem, we know that we're going to be starting with 4.76 kilometers because that's the value we're trying to convert. And we know that that number that we're trying to convert, is usually interpreted as being in the numerator. So when we go to set up our first conversion, we're going to note here that we want to cancel out the kilometers, which means kilometers needs to occur in the denominator of the conversion factor. And if our goal is to get to meters first, then that means we're trying to get to the unit of meters, which means that needs to be in our numerator. If I'm looking at the next conversion factor, I know that now that I'm in meters after using the first conversion factor, I want to cancel out meters. So meters goes on the bottom now. And on the top, I'm going to have picometers, which is that desired unit that I'm shooting for. So notice here that I can already sort of set up my conversion factor units pretty easily. just by paying attention to what my starting unit is, what my ending unit is, and how I want to get there. And also notice that basically each of these arrows that I have in my roadmap corresponds to a conversion factor that relates the two units between the arrow. So if you're having trouble kind of recognizing how to set up conversion factors or what conversion factors you need, this is one of the reasons why drawing out this roadmap can be really helpful, because it clearly outlines for yourself where you're headed with the units, and then, you know, based on where that arrow is located, the conversion factor is going to require the units on either side of the arrow. And so that kind of focuses you in on how to figure out your conversion factors that you're going to need. So I need a conversion factor that relates kilometers to meters. And the way that I typically do this is I go to the table and I say, okay, if I have one of this unit with the prefix, and it's important to start with the unit with the prefix, and I say I have one of them, then if I look in the table, kilo, I notice corresponds to 10 to the third. So what I'm going to do is I'm going to swap out kilo in this expression for times 10 to the third. So on the other side, I'm going to keep the 1. I'm going to add times 10 to the third instead of writing the little K symbol, and I'm going to keep the meters. And so you'll notice here that all I have done is swapped out the prefix for what it means in terms of its factor of 10. And I've kept the base unit, and I've kept the 1 out in front. Now this equivalence statement has the unit that we desire in this conversion factor that we're trying to get, and the unit that we're starting with, right? So it has the kilometers and it has the meters. And so all I have to do now that I've written out this equivalence statement is recognize what number is associated with each unit. So I have a 1 associated with the kilometer, which means that on the bottom here I should have a 1. And I have 1 times 10 to the third associated with the meters. So on the top here, I have 1 times 10 to the third. All right, let me do this one more time with the next conversion factor. That is going from meters to picometers. So again, starting with my unit that has the prefix, I'm saying, okay, 1 picometer is going to be equal to 1. And if I come up here to pico, I've got 10 to the negative 12. So times 10 to the negative 12 meters. So again, swapping out the prefix for the scientific notation, or that factor of 10. And so that's giving me my equivalence statement now. So if I go back again to the conversion factor that I've set up, I know I have to have picometers on the top. And if I look here, I have a 1 associated with picometers, so I put a 1 there. I know I have to have meters on the bottom, so I put 1 times 10 to the negative 12 because that's associated with meters in my equivalence statement. So 1 times 10 to the negative 12. When I go to type this into my calculator, I want to be very careful that these numbers in scientific notation are interpreted as one entire number. So the best way to do this is to use the E function on your calculator. And if you don't know how to do that, I might record a video or look for a video on YouTube that shows you how to use this, not the E function, I shouldn't say the E function, but it's basically something that expresses scientific notation, the times 10 portion of the scientific notation as an E. So if you know how to get access to this key, when you type in 1 times 10 to the third into your calculator, what it will actually look like is it'll be 1E3, and that's it. And so 1 uppercase E3 in your calculator is interpreted as 1 times 10 to the third, and it's interpreted as one entire number. Same thing with 1 times 10 to the negative 12. If you put in 1E negative 12 into your calculator, you're going to have something that the calculator interprets as one entire number. Now this is better than typing it out in your calculator as 1 times 10 to the third and using the multiplication symbol and using the exponent expression in the calculator, because your calculator will interpret that as a mathematical expression that needs to consider order of operations, where it's going to do the exponent first and it's going to do the multiplication second, and depending upon how you string together these numbers in your calculator, that could really complicate things. So I will do a video possibly specifically addressing that for those of you that are struggling with your calculator, because this problem, if you type it in your calculator incorrectly, you will get the wrong answer. And that mostly comes from the fact that we've got this 10 to the negative 12th on the bottom. And if you divide by 10 to the negative 12th, you're going to get a large value. But if you multiply by 10 to the negative 12th, you're going to get a small value. And if you're typing the numbers in incorrectly into your calculator, you will probably get a small value here because it will do the times 10 to the negative 12 as a multiplication step and not as a division step. So again, if that is confusing to you, I might record a separate video for explaining that. But otherwise, I'm going to keep moving here. So 4.76, I'm going to take that times 1 times 10 to the third, and then I'm going to divide that by 1 times 10 to the negative 12. And when I type that into my calculator, I get 4.76 times 10 to the 15th picometers. So my final answer here is 4.76 times 10 to the 15th picometers. Now, if we note here, we can think about whether or not this makes sense. So coming up here to the chart, anything below the base unit of 1 is a very small unit. So it represents a portion of the base unit, right? A milli is less than 1, right? So 1 millimeter is less than a meter. And it keeps getting smaller and smaller as you go down through here. So we know that these small units, if we have a lot of picometers, we know that because that's a small unit, we still don't necessarily have 1 full meter, right? There's a lot of picometers that are going to go into 1 full meter because this is a really small unit. We have the opposite effect when we go on the other side. These units are larger than the base unit, so that means that we have many of the base unit in each of these units. We know that a kilometer, for example, has 1,000 meters in it, 1,000 base units. So if we're looking at kilometers here, we know that this 4.76 kilometers is a really big number, right? That's a very far distance. Whereas picometers is a very, very small distance. So it makes sense that if we're starting with the value 4.76, that if we're converting this into picometers, which is a smaller unit, that we're going to have a lot of picometers because kilometers is such an extremely long length that if we measure it in terms of a very, very, very tiny length, then we should have a lot of that tiny length. And so that's why this makes sense that we went to such a large number with this conversion, because we started with a unit that it represents a long or a large value, and we're converting to a unit that represents a small value. So we have a lot of that small unit. So always pay attention to how that works in terms of thinking about what makes sense. So that is an overview of this first problem. Due to trying to keep these videos short, I am going to end the video for this first problem because that kind of covered a lot of different material. And I'll record a separate video right after this, sort of a part 2 for doing B, C, and D. So also, if you want to take the time to kind of, with what we talked about here, to try out B, C, and D, if you haven't yet, then this would be a good time to do that. And then you should watch part 2 of this video.